Hello everyone, here we have the application of differentiation for the problem optimization problems. The following are the steps for solving optimum problems. Step number 1. Identify the variable to be maximized or minimized. Let's say the variable y. Express variable y into a single variable function, or we can say y as a subject. And for the right hand side must be a single variable as well. Step number 3. Solve for f prime x equals to 0, or we can say identify the critical numbers or the problems. Step number 4. Verify the solution for f prime x equals to 0 by the second derivative test. Number 5. Get the optimum value of y equals to fx if it is required. Here we have the example. You have been asked to design a 1 liter oil can shaped as a cylinder. What dimension will be used the least material? So in order to fill up 1 liter oil can, meaning that we have to design the situation or the cylinder. So in here, the dimension will be used would be the area. So from the information, identify the variable to be maximized or minimized. So in here, the area is the variable. So let's open up the situation. We have a 2 circle and open up the body of the cylinder. So in here we have 2 pi r multiplied with h. The area for the circle will be pi r squared. So in here we have 2 circle, so meaning that the area will be equals to 2 pi r multiplied with h. We will obtain the area of the body plus 2 pi r squared, because we have to add on the 2 circle. Next, from the information given, 1 liter oil can refers to a volume. So in here, the volume is equals to 1000 ml or 1 liter. So the formula for volume would be V is equals to pi r square h. So from here, we are going to have a single variable, meaning that express A in terms of R or H. So by using the information given for the volume, so we will have 1000 equals to pi r square h. In order to express the situation in a single variable for the right hand side, so now let's h is equals to 1000 over pi r squared. So kindly substitute the h into the situation and we will obtain equation. So A is equals to 2 pi r bracket 1000 over pi r squared plus 2 pi r squared. Simplify and rearrange. So we will have 2000 over r plus 2 pi r squared. So now we will have step number 1 and step number 2. Express y, in this case it becomes a into a single variable function, meaning that a as a subject in terms of r. Kindly modify the situation. A is equals to 2000 r to the power negative 1 plus 2 pi r squared. Next, let's proceed for the third step. Solve for f prime x equals to 0. So in here, we are going to find the a prime, or we can say dA dr. So equals to 4 pi r minus 2000 r to the power negative 2. Rearrange the situation. And also find the second derivative. And we will have second derivative equals to 4 pi plus 4000 r to the power of 3. Rewrite the situation. 4 pi plus 4000 over r cubed. Next, find the critical value or the problems. dA dr equals to 0. Kindly substitute the situation. So 0 will be equals to 4 pi r minus 2000 over r squared. Rearrange the situation. We have 2000 over r squared equals to 4 pi r. So we will have 2000 equals to 4 pi r cubed. Rearrange the situation. R is equals to 2000 over 4 pi. We have a cube root. So finally, R is equals to cube root of 500 over pi. So that we have a critical value or a problems. Step number 4, verify the solution by using the second derivative test, meaning that substitute the r into the second derivative. So we will have second derivative equals to 4 pi plus 4000 over r cubed. So in here we will have 500 over pi. If we simplify the situation and rearrange the situation, so we will have second derivative equals to 4 pi plus, we will have 4000 pi over 500. So meaning that in here we will have 4 pi plus 8 pi. And second derivative equals to 12 pi where we have greater than 0. So if the situation is greater than 0, meaning that r equals to cube root of 500 over pi is a minimum value. For step number 5, get the optimum value of y equals to fx if it is required. So in here, what dimension will be used? The least material. So in here, we need to substitute the value r into the function where a is equals to 2 pi r squared plus 2000 over r. So if we substitute the value, r is equals to cube root of 500 over pi, and we will obtain a equals to 553.6 cm square. So here we are, and thanks for watching.